afternoon to everyone. Okay, so today we will discuss this problem. Evaluate a triple integral over v x plus y plus z into dx dy dz, where v is the volume of the rectangular parallel pipe bounded by x is equal to 0. X is equal to 0 is a plane, x is equal to a, y equal to 0, y equal to b, and z equal to 0, and z equal to c. Okay. So there are 6 planes here. This is a plane equation. So in this column, the limit is not given directly. Okay, so to find the limits, but it is very easy. Okay, you can easily find the limits. So here x varies from 0 to a, y varies from 0 to b, z varies from 0 to z. So you can easily write the limits. But for understanding purpose, I gave this explanation. But this explanation, there is no need to write in the examination. This is only for your understanding purpose. So the region of integration is the volume of parallel pipe, which is shown in the above figure, in which OA equal to OA is A, OB is B, OC is equal to C. Since the limits of the variables of integration are not given in the question, so we can choose order of integration arbitrarily. The reason is everything is constant. A, B, C are constant. That's why we can choose arbitrarily. So let us take the given integral I is equal to triple integral over V. The integrand is what? X plus Y plus Z. Either you can take dx dy dz or dz dy dx. But here in the book they took dz dy dx. Okay, the innermost integration is done with respect to what? Z, and then y, and then x. Okay, so if you integrate with respect to z, you should consider x and y are constant. So geometrically, x and y, x is constant and y is constant, jointly represent a line parallel to the z-axis. So this is the line. Okay, here x and y are fixed. Okay, z is vary in this line PQ. This is parallel to z-axis. So hence we draw an arbitrary line PQ in the region of integration, and we note the variation of z. We note the variation of z on this line as to cover the entire volume. So in this problem, z varies from 0 to c. Okay, here z is in the xy plane, z is 0. So in this plane, it is a c. Everywhere it is a c. This is a dash, c, b dash, o dash is z equal to c. So 0 to c. Okay. So since p equal to xy, because p is in the xy plane, so x comma y, and z is 0. The point q is, I told that already, x and y are fixed on that line, and z is c. Okay. Having performed the innermost integration with respect to z between the limits 0 and c, we get a double integral. As p takes all the positions inside the rectangle, since p take all the positions inside the rectangle OA C dash B, OA C dash B in the xy plane, the line PQ covers the entire volume of the parallel pipe. Hence, the double integral got after the innermost integration is to be evaluated over the plane region OA C dash B. So in this region, okay. So in this, the innermost integral take care of the height, okay. The next integral, okay, the next two double integral, it will take care of this uh, okay, this region. Okay, so then if you take the triple integral, then it will cover the entire parallel pipe. Okay, so the limits for the double integral can be easily seen. Okay, y varies from 0 to b and x varies from 0 to a. So now I will go to the problem. So I equal to triple integral z varies from 0 to c, y varies from 0 to b, x varies from 0 to a, x plus y plus z into dz dy dx. Okay, so now integrate first with respect to z. With respect to z means you will get what? Xz plus yz plus z square by 2. The limit is from 0 to c dy into dx. So substitute the limits. If you substitute the limits, x is equal to 0 to a, y equal to 0 to b, z equal to what? C. So xc plus yc, okay, plus c square by 2. Lower limit is 0, 0, 0. Okay, so just leave it. So into dy into dx. Next, you should integrate with respect to y. X is equal to 0 to a. So if you integrate with respect to y, you will get what? X c, okay, into y plus c into y square by 2 plus c square by 2 into y. The limit is from 0 to b into dx. So substitute the upper limit for y. X varies from 0 to a. X c b, x c b, and then c b square by 2 next c square b by 2. Again, lower limit is 0 into dx. Now integrate with respect to x. bc is constant, x square by 2 plus b square c by 2 is constant. Integration of dx is x plus b c square by 2. Integration of dx is x. The limit is from 0 to a. Substitute the limits for x. A square bc by 2 plus a b square c by 2 plus a b c square by 2. Lower limit is again 0. I think what is common? A
BC.
B
ABC.
C, yeah, A B C by 2 is common. Remaining is here A, here B, here C. So A plus B plus C. So this is the final answer. So next, we will discuss double integral using beta gamma function. Already we discussed problems in beta gamma function. Okay, and also we know how to solve the problems in double integral as well as triple integral. Now, this topic is concerned at evaluation of double integral using beta and a gamma function. Similarly, we will discuss evaluation of triple integral using beta and gamma function after finishing this topic. The first problem, prove that this is somewhat important result, 0 to a. I will use this result in the upcoming problems. Y power m minus 1 into a minus y whole power n minus 1 into dy is equal to a power m plus n minus 1 into beta of m comma n. Solution. Okay, let us take the left hand side. The left hand side is 0 to a y power m minus 1 into a minus y whole power n minus 1 into dy. So here I am going to take a commonly. So here have a power n minus 1. A is constant. If you take a commonly, a power n minus 1 into integral 0 to a y power m minus 1 into 1 minus y by a whole power n minus 1 into dy. So let us take this y by a is equal to some t. Okay, so let us take y by a equal to some t. Okay, so this integral is equal to a power n minus 1. What about the limits? When y equal to 0, t is also 0. When y is a, t is 1. So the limit is from t equal to 0 to 1. What is y? Y equal to at. So at power m minus 1. Okay, 1 minus y by a is t. 1 minus t whole power n minus 1. And from this dy, okay, what? Dy equal to what? A into dt. So dy equal to a into dt. So this is equal to how many a you have? A power n minus 1, a power m minus 1 into a. So a power m plus n minus 2 plus 1 minus 1. Integral 0 to t power m minus 1 into 1 minus t whole power n minus 1 into dt. So what is this integral?
0 to 1, sir. Integral.
Yes, correct. Prashanta.
Yes, sir.
Is it Prashant?
Yes, sir.
Yes, okay. So this is a power, so a power m plus n minus 1. This is a beta of m comma n. So that is result I need to prove. In the next slide I will write this is equal to a power m plus n minus 1 into beta of m comma n. Okay. So write the next second problem. So evaluate double integral xy into 1 minus x minus y, okay, whole power half into dx into dy over the area enclosed by the lines over the area enclosed by the lines x is equal to 0, y equal to 0, and x plus y equal to 1 in the positive quadrant. Solution. So let us, but here the region is given, but it is not, the limit is not given. So we need to find the limits. Okay. So first I will draw the region and then find the limits. This is x-axis, so this is y-axis. This is y equal to 0. This is x equal to 0. This is the line x plus y equal to 1. Okay. So now, so either you can take a strip parallel to x-axis or parallel to y-axis. Okay. That is here you can take anyway. So suppose if I take the strip parallel to y-axis, what happened? I equal to integral. Here in this strip y is varying. Y varies from where to where? 0 to 1 minus x.
X. 1
Yeah,
minus x.
yeah, x varies from where to where? X varies from 0 to 1 into x power half, y power half into 1 minus x minus y whole power half dx dy. Okay. So first, sorry, dy dx. dy dx. So this is equal to integration x is equal to 0 to 1. Okay, I will write x power half here, and then y equal to 0 to, instead of 1 minus x, I will take a. Okay, instead of 1 minus x, just consider it is a. Y power half. Similarly here, this 1 minus x I will replace by what? A. So a minus y whole power half into dy into dx. Okay, where 1 minus x is equal to a equal to 1 minus x. Okay. So now I need the value of this one, the bracket, the square bracket. What is the value of this integration 0 to a y power half into a minus y whole power half into dy? Anybody?
Beta.
Purnachandra?
Beta of 3 by 2 comma 3 by 2.
Beta of 3 by 2 comma
3 by 2.
3 by 2. That is enough or something else you need to write?
A power 3 by 2 plus 3 by 2 minus 1.
A power 3 by 2 plus 3 by 2 minus 1 into beta of 3 by 2 comma 3 by 2. Okay, right? So actually this result,
2,
integration 0 to a
power 5.
Y power m minus 1 into a minus y whole power n minus 1. Okay, right? So I will write here 0 to a y power m minus 1 into this a. Okay, right? A minus y whole power n minus 1 into dy. So is equal to this a power m plus n minus 1 into beta of m comma n. So if you compare this left hand side with the integral in the square bracket 0 to a y power m minus 1 equal to half, so m equal to 3 by 2. Okay, again a minus y whole power half, n minus 1 equal to half means n equal to 3 by 2 into. So now if we use this result, suppose this question is asked in the examination, okay, you can use this result, but otherwise here in this step you need to take what?
A common.
A common. Very good. In this step take a common and you should proceed as it is and you should derive this result and then you can proceed further. That is a little bit better. Okay. So integration x is equal to 0 to 1. Okay, x power half, x power half. So what you told that a power m plus n, that is the 3 by 2 plus 3 by 2 minus 1 into beta of m comma n, 3 by 2 comma 3 by 2 into dx. So this is equal to integration x is equal to 0 to 1 x power half, but we know that
1 minus x the whole square.
Power whole square. This is 3 minus 1 2 into beta of 3 by 2 comma 3 by 2. Thank you, Dr. Turman. Into dx. So beta of 3 by 2 comma 3 by 2 is constant. So I will take outside the integral 3 by 2 comma 3 by 2 into integral 0 to 1 x power half into 1 minus x whole square into dx. What is this value? What is this?
Beta of 3 by 2 comma 3 by 2.
Purnachandra,
Comma 3.
Purnachandra, your voice is breaking.
Yes, sir.
Your voice is breaking. I not
3
hear.
by 2 comma 3, sir.
Yeah, 3 by 2 comma 3. Yes, correct. Purnachandra, I think Purnachandra also gave the same answer. Thank you, Prashant. So now, so if you know the beta gamma function, then it is very easy to, okay, the evaluation of the integration is very simple. Otherwise, it is a little bit lengthy sometimes. Okay, so that's why that is the use of beta and gamma function. The remaining part is you should apply Chandra, please mute. Okay. So now use the relationship between beta and gamma function. So this is gamma of 3 by 2 into gamma of 3 by 2 into gamma of 3, okay, into gamma of 3 by 2 into gamma of 3. Gamma of 3 by 2 plus 3 is gamma of 9 by 2. Okay, simplify this one. Gamma of 3 gets cancelled. So the numerator you have gamma of 3 by 2.
Gamma of 6 by 2. 3 by 2 plus 3 by 2. Oh, okay, sir. Okay, sir.
Correct number 6 plus 9.
Correct.
Okay. So gamma of 3 gets cancelled. The numerator gamma of 3 by 2 whole cube. The denominator you have gamma of 9 by 2. Gamma of 9 by 2 you can write 7 by 2 into 5 by 2 into 3 by 2. Okay, 3 by 2 into what? 1 by 2 into gamma of half is root pi. So numerator is this is gamma of 3 by 2 is what? 1 by 2 into root pi whole cube. So this is 35105 by 16 root pi. So this is equal to if you cancel this root pi whole square pi this is 16 by 2. 16 by 2 is 8. Okay, sorry, 16 by 4. This is 2 cube is 8. Okay, or 2 cube is 8. So 16 by 8 into 105. So 2 pi by 105. So this is the final answer. Okay. Next problem, please write down. Find the area of the asteroid. Using gamma function. So what is the asteroid equation? Anybody? What is the asteroid equation? Otherwise, asteroid, okay, you know the diagram of asteroid?
No, sir.
No. Okay. So asteroid equation is x power 2 by 3 plus y power 2 by 3 equal to a power 2 by 3. Okay, sometimes they will give the equation in the question, sometimes they don't give the equation. So you should know the equation of the asteroid. Okay, the equation of the asteroid is x power 2 by 3 plus y power 2 by 3 equal to a power 2 by 3. Okay. So the diagram for asteroid நிறைய பேர் வீட்டில் காலம்பரை இதெல்லாம் போட்டிருப்பாங்க. ஓகேவா, ஈஸியாக போட்டுடலாம். Okay. So this is the strike. Okay. ஆக்சுவலாக முதல்ல பொண்ணுக்கெல்லாம் போட்டுட்டு இருந்தாங்க கோலம். ஓகேவா, இப்போ யாரும் போடுறதில்ல. ஓகேவா, வாட் இஸ் த ஏரியா ஆஃப் த அஸ்ட்ராய்ட்? எனிபடி? Area of the asteroid? Okay, so that is we are going to find now area of the asteroid. Okay, so area equal to double integral over r into dx dy. So this is the area, but here the region r is it is including everything. This is region r. Okay, region r. But now I am going to find the area of only this portion. Okay, this portion, because due to symmetry I am going to multiply by 4. So by symmetry, record area is equal to 4 times double integral. I'll call some name. Okay, the origin O, this is A, this is B. Okay, so okay, so if you want to say this is something, this portion is C. Okay, so okay, so this is O, A, C. C is not a point. Okay, this portion. Okay, C, D, dx dy. So this is the required area. Now here I am going to give some substitution. So using the substitution, the problem is a little bit simpler. Okay, so here what is the asteroid equation? X power 2 by 3 plus y power 2 by 3 equal to a power 2 by 3. This is asteroid equation. Throughout divide by a power 2 by 3, we will get x by a whole power 2 by 3 plus y by a whole power 2 by 3 is equal to 1. Okay, so I need in the form of x plus y equal to 1. Okay, then it is a little bit easier for me. Okay, so that's why I'm going to take this is x, entire thing is x. Okay, plus this is a capital, this is capital X, this is capital Y equal to, where capital X is equal to x by a whole power 2 by 3 and capital Y equal to y by a whole power 2 by 3. Okay, so now from this I am going to find the small x. Okay, what is x by a? X by a equal to capital X power 3 by 2. This implies x is equal to a into capital X whole power 3 by 2. This implies dx is equal to, okay, dx is equal to what? 3 by 2 into a capital X power 3 by 2 minus 1 is half into capital dx. Similarly, y by a, y by a equal to capital Y whole power 3 by 2 implies y by a, sorry, y equal to what? A into y power 3 by 2. This implies dy equal to 3 by 2 into a capital Y power half into dy. Okay. So now I need to evaluate I. Okay, take this is I equal to 4 times double integral over. So now the region of integration. So I will write in the next page the region of integration is given by here originally in the small x small y. Okay, here what is the region of integration? X is positive because of the first quadrant, y is positive, and it should be lies x by a whole power 2 by 3 less than or equal to 1 inside the asteroid. So this is the region of integration in the small x small y plane. Okay. So the region of integration is given by the small x is greater than or equal to 0, comma, small y is greater than or equal to 0 because it is in the first quadrant, and it satisfies x by a whole power 2 by 3 plus y by a whole power 2 by 3 less than or equal to 1. So inside the asteroid. Okay, so that is the region of integration in capital XY plane. This is small XY plane. Next, capital XY plane is given by please tell, the region of integration in capital XY plane is given by what?
X is greater than or equal to 0.
Small x or capital X?
Capital X.
Yeah, capital X is greater than or equal to 0.
Capital Y is greater than or equal to 0.
Capital Y is greater than or equal to 0.
Capital X plus capital Y less than or equal to 1.
Very good. Capital X plus capital Y less than or equal to 1. Okay, well, because small x greater than or equal to 0, that's why capital X, small y greater than or equal to 0, capital Y. So we know that this is capital X, this is capital Y. So capital X plus capital Y less than or equal to 1. Okay. So now for this I am going to draw the region capital X, this is capital Y, this is capital X plus capital Y equal to 1. Okay, now this is R. This is R. So here you can take a strip either parallel to x-axis or parallel to y-axis. So if you take a strip parallel to x-axis, area equal to, what is the area? 4 times double integral over R, this R, okay, R. Originally it was OACD, now it is over R into dx dy, okay, dx d capital X into d capital, d, yeah, dx, what is dx? Dx is what? 3 by 2 into a x power half into dx, 3 by 2 into a x power half into dx into d capital X, this is capital X, into 3 by 2 a y power half into d capital Y. Integral. Here in the strip x is varying, x varies from capital X. Capital X is equal to 0 to capital X is equal to here 1 minus y, and y varies from here, this is 0 comma 0, this point is 0 comma 1, y varies from 0 to 1. What is the integrand? The integrand is x power half into y power half into dx into dy. Now I am going to integrate with respect to x. First, keep y is constant. 9a square. Integration capital Y equal to 0 to 1. This is capital Y equal to 0 to 1. Capital Y power half. If you integrate x power half, you get x power 3 by 2 by 3 by 2. Limit is from where to where? 0 to 1 minus y into d capital Y. So this is 18 by 3. 18 by 3 is 6a square. Integration from 0 to 1. Y power capital Y power half into upper limit 1 minus capital Y whole power 3 by 2 into dy, because lower limit is 0. So what is this integral? Rahul. This Rahul is here.
Sir, yes, sir.
Yeah, what is the integral? Integral 0 to 1 y power half into 1 minus y whole power 3 by 2.
Beta of 3 by 2 comma
3 by 2 comma
5 by 2.
Oh, okay. So you should add 1. Okay, wow. Okay, correct, Rahul. Now this is equal to 6a square. Beta of 3 by 2 comma 5 by 2 using the relationship between beta and the gamma function. Okay, wow. So who is ready to tell? Beta and gamma function.
Gamma of m
Gamma of
3 by 2
3 by 2
into gamma of 5 by 2 by
gamma of 5 by 2 by
gamma of 3 by 2 plus 5 by 2.
that is 8 by 2.
4, sir.
Yeah, 4. Yes, correct. Thank you, Purnachandra. So this is 6a square. Gamma of 4 is 3 factorial. Okay, 3 factorial. Gamma of 3 by 2 is what? 1 by 2 into gamma of 1 by 2 into root pi.
Root pi.
Yes, into gamma of 5 by 2 is 3 by 2 into 1 by 2 into root pi. So 3 factorial is 6, so 6 and 6 gets cancelled. A square, 3a square, okay, root pi into root pi, pi, 8. So the area of asteroid is 3a square pi by 8 square unit. So you should remember this result. Okay. Suppose if you don't get it, you can trace back where you done the mistake. That's what you should remember.
Sir, one show, sir.
Okay.
Thank you, sir.
Okay. So now the next problem is just I'm going to give some idea only. Okay. So you should complete the problem. Evaluate. Sorry, not evaluate. Find the area of ellipse x square by a square plus y square by b square equal to 1 using gamma function. Okay. So now I am not going to solve each and every step. The idea, this is the ellipse. So again, I am going to find the only, because due to symmetry, I am going to concentrate only the positive quadrant and I multiply by 4. So area of the ellipse is equal to 4 times what? Double integral O A C B. So O A C B dx d. Okay. So here, what is the equation we have? X square by a square plus y square by b square equal to 1. So as I told already, I need in the form of what? Capital X plus capital Y equal to 1. So that's why I will take, this is entire thing is capital X, entire thing is capital Y. So where capital X is equal to small x square by a square, capital Y equal to capital Y equal to y square by b square. Okay. Now from this, I need x. Okay, x by a equal to root x. So this implies dx is equal to a into 1 by 2 root x into dx. Similarly, y by b equal to what? Y by b equal to root y. I need a dy. Okay, or dy. What is a dy? b by, if you differentiate root y, you get to 2 root y into dy. Okay. So now, so the story learn சொல்ல ஓகேவா, the region of integration in the small x or small y. Okay, if you want, you can write, because for one problem I gave it explicitly, so you should write for the remaining problems. Now area equal to area equal to 4 times double integral over r. R is here. This is capital X, this is capital Y. This is 1x plus y equal to 1. This is a capital R into dx dy. Okay, what dx dy is what? A b by 4, a b by 4 into 1 by root x into root y into d capital X into d capital Y. I just multiply these two. Okay. So 4 gets cancelled. Okay, AB double integral. Okay, what? So if you take a strip parallel to x-axis, what happened? Capital X is equal to 0 to 1 minus y. Y varies from, this is 0 comma 0, this is 0 comma 1. Y varies from 0 to 1. Okay, and then x power minus half, y power minus half into dx into dy. Okay, so now AB integration capital Y equal to 0 to 1. So I'll write y power minus half here because I am going to integrate with respect to x. So if you integrate x power minus half plus 1, that is minus half plus 1 is x power half divided by half. Limit is from 0 to 1 minus y, capital Y, into dy. So this 2 is going to the numerator. So this is equal to 2ab integral 0 to 1 y power minus half. Apply the limits for x. 1 minus y whole power half into dy. Now I need the value of this integral in terms of beta function. So who is ready to tell? Shailaja?
Sir, answer is pi AB, sir.
Sorry, Purnachandra, please tell.
Answer, sir. Answer is pi AB.
Answer is pi AB. Yes, very good, Purnachandra. Very good. So we know that the area of the ellipse is pi AB. I think you got it. The final answer is also correct. Okay, please tell what is the value of this integral?
0,
2AB
2AB into beta 1 by 2 comma
beta of
1 by 2,
1 by 2 comma
3 by 2.
yeah 3 by 2. Yes. Okay. Now this is equal to 2AB into beta of half comma 3 by 2. Use the relationship between beta and gamma function.
Root
Gamma of half
into
gamma of 3 by 2 divided by gamma of 2. Okay. This is 2AB by gamma of 2 is okay. Gamma of half is root pi. Gamma of 3 by 2 is 1 by 2 into root pi divided by 1 factorial. So 2 gets cancelled. So this is pi root pi into root pi pi AB. Pi AB is the final answer. Okay. The next problem, evaluate double integral x power m minus 1 into y power n minus 1 into dx dy okay over the positive quadrant of the ellipse. Over the positive quadrant of the ellipse x square by a square plus y square by b square equal to 1 in terms of gamma function. So my first question is, what is the main difference between this problem and the previous problem? At least you should tell.
Yeah. So, in terms of question wise, I have given.
Purachara, you are telling the answer. Sorry, I can't hear your voice properly today. I don't know why.
So in previous answer, they have asked you to find out the area, sir.
Yeah, yes, that means a double integral dx dy.
Zero.
Here you have what? The integrand is what? X power n minus 1 into
That is what.
y power n minus 1 is extra into dx dy. Second difference is the previous problem.
whole ellipse, sir. இதுல
Very
1
good,
over
very good,
positive
very good.
quadrant.
Whole area, okay, va? Whole area. Here only positive quadrant, okay, va? I think I gave this problem is a practice problem, okay, va? Because already I solved a similar type of problem. Okay, just I will give the rough idea. Okay, so what is the so can, okay, area equal to, so please tell, you should tell, any one of them tell. Just I'm not going to do by again step by step, just a double integral, okay, what dx dy, yeah, sorry, not the area here, here I, here I is x power n minus 1 y power n minus 1 into dx dy, okay, va, over the ellipse வந்துட்டு x axis y axis only this portion R, okay, va? So here again OACB, okay, so now this is over OACB. So now after the from, I think this is capital X, this is capital X, this is capital Y. Can anyone tell what is the integral after substitution? So please tell. What is dx?
a by 2 root x.
A by, I will write here, a by 2 root x into dx. Okay. What is dy?
b by 2 root y.
B by 2 root y into dy. Okay, in the part, okay. I need a small x. What is a small x?
a root x.
A root x, because the capital X is equal to x square by a square, na? Okay. X by a equal to what? X by a equal to root x. So x is equal to a into root x, correct? A into root x whole power what? M minus 1 Similarly, y is what?
b into root y.
B into root y.
Y. Y.
B into root y whole power n minus 1 over the region R. R is here. This is x, capital X. This is capital Y. This is capital X plus capital Y equal to 1. Okay. So now what is constant? A power m. M minus 1. Here have A. So A power m and b power n minus 1 into b. So b power n double integral over this is r equal to r. Okay, here x power what? X power m minus 1 by
M
2.
minus 1 by 2.
Okay, or m by 2 minus 1 by 2. Here you
Minus
have
1 by
what? Here you have root x.
Minus 1 by 2.
So minus half, and then y, capital Y power n minus 1 by 2 or n by 2 minus 1 by 2. Here you have denominator have y, root y. So minus half into dx d capital X into d capital Y. Okay. So now this is yes.
Sir, A power M into B power M by 4. No, sir.
I will do it. Okay. I think I will do some Purnachandra. Please wait a little bit. Okay.
Sir, you forgot to write 2, sir, in denominator.
By 4 2 into 2 4.
Yes, sir, that.
Yes, yes. Thank you. Okay. So a power m into b power n by 4. Okay. Take a strip either parallel to x-axis or parallel to y-axis. If you take a strip parallel to x-axis, what you have? X is equal to, capital X is equal to 0 to 1 minus y. Y varies from 0 to 1. Okay. X power m by 2 minus 1. Y power n by 2 minus 1 into dx into dy. So next step I am going to integrate with respect to x. A power m into b power n by 4 integral y equal to 0 to 1. Y power n by 2 minus 1 is constant. Okay, if you integrate x power m by 2 minus 1 with respect to x power m by 2 by m by 2. The limit is from 0 to 1 minus y into dy. Okay, so here 2 4 so I will write m, then I will write here m by 2 m into a power m into b power m b power m by
2.
2. Okay, and then integral 0 to 1 y power n by 2 minus 1. Upper limit is what? 1 minus y whole power m by 2 minus 0 into dy. So what is the value of this integral? Beta of
n by 2
n by 2
comma m by 2 plus 1.
very good, Vetri. So this is now use the relationship between beta and gamma function. M by 2 into a power m into b power n.
Sir, m should be in the denominator, sir.
Yes, sir. A by
Yes.
m, b by n.
Thank you. m is here. So this is equal to 2 by m, 2m, gamma of n by 2. This is a gamma of m by 2 plus 1 by gamma of, you need to add these two. Okay, so m by 2 plus n by 2 plus 1. In the next step, I am going to apply the recurrence formula for gamma of m by 2 plus 1, a power m into b power n by 2m. Please write a charger. Now, this is gamma of n by 2. Okay, you can write gamma of m by 2 plus 1 is what? M by 2 into gamma of m by 2 divided by. So this is actually what? Gamma of m plus n by 2 plus 1. So you can cancel m and m. The final answer is a power m into b power n by 2 into 2, 4. Gamma of m by 2, gamma of n by 2 divided by gamma of m plus n by 2 plus 1. So this is the final answer.
So can we use the recurrence formula in denominator also?
Denominator, if you use it, okay, you can use it, but you cannot cancel. Okay, well, that's why I'm not using. Okay, if it is possible to cancel any term, you can use it, but you can stop here or you can use it.
Thank you, sir.
Actually, the next problem is comes under beta gamma function only. Is not comes under multiple integral. Prove that integral 0 to infinity e power minus x, e power minus ax into x power n minus 1 into dx gamma of n by a power n, where n and where a and n are positive, where a and n are positive. So using this result, you should find, hence find the value or deduce the value of integral 0 to 1 x power q minus 1 into log of 1 by x whole power p minus 1 into dx. Solution. So let us take the left hand side, integral 0 to infinity e power minus ax into x power n minus 1 into dx. So take ax is equal to some t. Okay, so then e power, what about the limits? I think when x is equal to 0, t 0, when x is equal to infinity, t is infinity, so there is no change in the limits 0 to infinity e power minus t. What is x? X is equal to t by a whole power n minus 1. Okay, what is the dx? Dx is equal to dt by a. So dt divided by a. So this is equal to 1 by a power n, n minus 1 into a power n, integration 0 to infinity e power minus t into t power n minus 1 into dt. So the value of this integral is what?
Gamma of n.
Gamma of n is correct. 1 by a power n into gamma of n. The left hand side is what? The left hand side integral 0 to infinity e power minus ax into x power n minus 1 into dx. The first part is over. Okay. The second part, what is the second part? We should find the value of the integral. I'll take this I equal to 0 to 1, 0 to 1, x power q minus 1, x power q minus 1 into log of 1 by x, log of 1 by x whole power p minus 1 into dx. Okay. So now, so I'll give you a hint. Okay, your substitution will give from 0 to 1 to 0 to infinity. And also the integrand should be this form. Then only I can use this result. So what is the substitution? So again I will repeat. So you need to give the substitution here. Your substitution will give x when x is equal to 0 to 1 2 means it is either 0 to infinity or infinity to 0. Okay, that is not a matter. Okay, either 0 to infinity or infinity to 0. And the integrand should be like this, in this form. You should think about and tell the correct substitution.
Sir, 1 by 2 is
Sorry, Purnachandra?
1 by 6.
Sorry, anybody got the substitution? I don't get I don't get it clearly. Suppose if you know what Purnachandra is,
Sir, x is equal to 1 by 6.
x is equal to 1 by t. No. No. If you take log of 1 by x is equal to some t, okay, what is 1 by x?
E power t.
E power t. Okay, 1 by x is equal to e power t. Okay, x is equal to
E power minus t.
e power minus t. Okay, now when x is equal to 0, t should be what?
Infinity, yes, sir.
Yes, infinity. Correct, Google. Because e power minus infinity is 0. when x is equal to 1 ஆகும்போது t is what?
0.
0. ஓகேவா? So t varies from infinity to 0. What is x? E power minus t whole power q minus 1. ஓகேவா? Into log of 1 by x is what? T power p minus 1 into dx. What is dx from this? E power minus e power minus t into dt. So minus e power minus t into dt. Because of this minus, I will interchange the limits 0 to infinity. Okay, e power minus t into q minus 1 into t power p minus 1 into e power minus t into dt. So this is equal to integration 0 to infinity. Okay, e power minus q is constant minus qt e power plus t, here have e power minus t gets cancelled into t power p minus 1 into dt. Okay, so the substitution is, let us take log of 1 by x is equal to t. So now what is the value of this integral?
Gamma p by q power n, q power p.
Very good, very good, very good. So I should use this result. Okay, so instead of a, here have q, instead of n I have p. That's all. So n we have p. So gamma of p by q power, because a, instead of a I have what? Q power a power n is what? P. So gamma of p divided by q power p. And the last column, okay, show that integral 0 to infinity x power n e power minus a square x square into dx is equal to 1 by 2 into a power n plus 1 into gamma of n plus 1 by 2. Reduce that integral 0 to infinity e power minus a square x square into dx is equal to root pi by 2a. Hence, show that integral 0 to infinity cos of x square into dx is equal to integral 0 to infinity sin of x square into dx is equal to 1 by 2 into root pi by 2. So I think it may looks a little bit bigger, but maximum I will finish it 10 minutes. Okay. So first we will do the first subdivision. So what is the first subdivision? Here we have integral 0 to infinity x power n into e power minus x square into dx. Okay, wow. So what is the substitution we can give here?
A square.
A square x square equal to
T.
root t or t.
Root T, sir.
Yeah, a square x square equal to t. Okay, wow. So yeah, okay, a square x square equal to t. So that means substitute, put ax is equal to t. Okay, ax is equal to t. This implies a square x square equal to t square. From this dx is equal to dt by a. What is the integral? I equal to integral 0 to infinity x power n e power minus a square x square into dx is equal to, when x is equal to 0, t 0. Okay, wow. When x is equal to infinity, t infinity. What is x? T by a. Okay, what? T by a. Uh, okay, I think ax is equal to root t. If you take it is root t, okay, so then it is what? T. Okay, because e power t square means it is a little bit difficult. Okay, so then what is dx?
1 by 2 root t by a.
Dx is equal to 1 by 2 root t a denominator. Is it correct, Gogul?
Yes, sir.
Okay. நீ சொல்ற நான் இங்க எழுதுறேன். Okay. 1 by 2 a root t. Okay. Here 0 to infinity x. What is x?
Sir, dt, sir.
Okay. So dt. So what is x? X is root t by a. Root t by a whole power n e power minus x, a square x square is what? T. What is dx? 1 by 2a root t into dt. So now this is equal to integral 0 to infinity. Okay, a power n, here have a power 1. So 1 by a power n plus 1. Okay, 1 by a power n plus 1. What is the integrand? I think 2 is also constant. So I will take 2 is also constant. I will take it out. What is the integrand? T power n by 2. T power n by 2. This is t power n by 2. Here have what? Root t. So t power minus 1 by 2 into e power minus t into dt. So this is equal to, I will write in the next page, 1 by 2a, 1 by 2 a power n plus 1 integral 0 to infinity, okay, e power minus t into t power what?
n minus 1.
N minus 1 by 2. Okay, n minus 1 by 2 into dt. So what is the value of this integral? Gamma of n minus 1 by 2 plus 1 because this is what? Gamma of n plus 1 by 2. Is it correct? The reason is, what is gamma of n? Interval 0 to infinity e power minus x into x power what? N minus 1 dx. If it is n minus 1, here n. So that's why I'm adding here 1. So the first part is over. What is the left hand side? Left hand side is integral
0 to infinity
0 to infinity.
e power minus a square x square dx.
First part, x power n, x power n e power minus a square x square into dx.
Yes, sir.
First part is over. So second part, how to reduce the second part? We need to substitute in equation 1. In equation 1, put I don't have this term, so I need to substitute n equal to what?
Zero.
Yeah, zeros. Okay, thank you, Shailaja. Correct. N equal to 0. So now 0 to infinity. So e power minus a square x square into dx. So that is equal to 1 by 2 a 1 by 2a into gamma of half. So this is root pi by 2a. So this is also over now. Okay, second part is also over. From the second part to third part, from here to here, what I need to substitute? Anybody? If I want to get from this equation, I want to get this integral and this integral. For this, I need to substitute what? So first you need to substitute and then you should compare the real and imaginary part. Okay, va?
Sir, that trigonometric functions are, sir.
Correct. Now, a square equal to what?
Sin square, sir.
Yeah. So now a square is equal to what? So we should substitute here a square equal to minus I. The reason is, if I substitute a square equal to minus I, you will get what? E power I x square. E power I x square is nothing but cos x square plus I sin x square. We call this is 2 into substitute a square equal to minus I. So from this you have integration 0 to infinity e power ix square dx. Right hand side is what? Root pi by 2 into a is root of minus I. This is equal to root pi by 2 multiply and divide by root I. So root of minus I into I. So this is equal to root pi by 2 root I. What is the denominator? Denominator is I square minus 1, so plus 1 root 1. So the numerator is root I, so root I by 1. So this is equal to root pi by 2. Okay, root I you can write what? Cos pi by 2 plus I sin pi by 2 whole power half, because I you can write cos pi by 2 plus I sin pi by 2. So using De Moivre theorem you can write this is root pi by 2 into cos pi by 4 plus I sin pi by 4. So this is equal to root pi by 2. This is 1 by root 2 plus I 1 by root 2. So the left hand side is what? 0 to infinity e power I theta form cos of x square plus I sin x square into dx. Compare the real part. If you compare the real part, 0 to infinity cos of x square into dx is equal to root pi by 2 root 2. If you compare the imaginary part, 0 to infinity sin of x square into dx is equal to root pi by 2 root. I think I gave this result. Sorry. Yes, root pi by 2 root. Okay. So we will discuss the remaining problem in the next class. Suppose if we have, I think yesterday some of the students asked the doubts regarding the assignment problem number 20. Purnachandra and Vetritramohan, 24.
4, sir.
And I think I gave some idea. You should convert Cartesian into what?
Polar.
Sir, we'll try, sir.
Got it?
We'll try, sir.
We'll try, sir.
We will try. Okay, try. Otherwise, that is the first step I gave. Okay. So suppose if you don't get it, please send me the message. Okay. So what is the? Just I'll give one more idea. Try. This is a hint for the assignment problem. Okay. So actually, you have what? The integral 0 to 2a x into root of, is it correct?
Beta gamma we can do, sir.
2ax minus x square.
2ax minus x square into dx.
Yes, sir.
I think there is one more integration. I think so. Double integral 0 to 2a.
Integration 0 to root over 2ax minus x square.
Root over 2ax minus x square into
X dx.
x dy dx.
Yes, sir.
So y then is there.
Hi, sir.
Okay. I told that x is equal to what?
r cos theta,
r cos theta,
r sin
r
theta.
sin theta.
Okay, and then here here y equal to, this is 0 to, this is actually y adu, this is y thane.
Yes, sir.
Y equal to 2ax minus x square. Okay, if we square this one, we'll get what? Y square equal to 2ax minus x square, or x square plus y square equal to what? 2ax. What is x square plus y square?
R square.
Yeah, r square. Okay, 2ax, this is x. 2a, what is x?
R cos theta.
R cos theta. So r equal to, you can cancel r equal to 2a cos theta. Okay, so this is the upper limit. This is the upper limit. The lower limit is 0. So the integrand is r equal to 0 to r equal to 2a cos
2a cos
theta.
theta.
And theta varies from where to where? Because in the first quadrant, the circle is in the first quadrant, it is a 0 to pi by 2. The integrand is what? X. What is x? R cos theta. And the dx dy, I think I gave some formula, Jacobian like this. Dx dy. Okay, dx dy equal to modulus of j into dr into d theta. So j is nothing but, what is the Jacobian j? J is a determinant of dou x by dou r, dou x by dou theta, dou y by dou r, dou y by dou theta. So if you substitute dou x by dou r is what? So please tell quickly. Dou x by dou r. Cos theta. Next, dou x by dou theta minus r sin theta. Okay, and then dou y by dou r. What is dou y by dou r? Sin theta.
Sin theta.
Yes, please tell me.
R cos theta.
R cos theta. Okay, now this is what? R cos square theta plus r sin square theta. This is equal to r. So j equal to r. So dx dy equal to r into dr into d theta. So now, yes, here. So yes, here. Okay. LD I wrote what? X I wrote r cos theta. Dx dy or dy dx is r into dr d theta. So I need to evaluate this integral only. Okay, I will write this integral the next page. Okay. After that I will write. So what is the I equal to integral 0 to pi by 2, theta is equal to 0 to pi by 2, r equal to 0 to 2a cos theta, 2a cos theta into, what is the integrand? R square into cos theta into dr into d theta. The remaining part you need to do it. The final answer is, you know that I equal to pi a cube by, I think you can easily get it from hereafter. Okay, try. Okay, that's all. Okay, thank you everyone. Thank you,
Thank
Gogol.
you, sir.
Thank you, Vetri.